So this stuff is up, and I might have gone over this before, but it's always good to review it. So this is up, I believe it's in either class 7 or class 8 in the class materials folder. So we're going to talk today about dealing with audio, and we're going to work on compression and EQ, and we're going to talk about phase a little bit, and I'll show some stuff in context of another mix, and hopefully this stuff will help you with the pieces that you're working on mixing. So basic audio wave shapes. The most important characteristic of sounds that have a definite pitch is that they have a repeating waveform. So that means anything that has a pitch like A flat, E, a repeating waveform. That means we can go from this point here to here and then here. And you see how that repeats, right? And this is something called a sine wave. So in a synthesizer, and we'll use that to start with now because I want to get into a discussion of phase in a second. But with audio oscillators, we can generate what are considered to be the 4 most basic waveforms: sine, triangle, square, and sawtooth, or what's also called ramp waves. These waveforms in that order represent a steadily increasing complexity of shape and of timbre as the number and strength of the harmonics for each waveform increases. So, this is a sine wave. It sounds like the lowest of the samples because it's only playing the fundamental frequency. So everybody knows that I did that whole thing with the Hammond organ plugin where I showed how you have the fundamental and then the overtones above it. And that creates up, depending upon the volume of the overtones and the relationship with the fundamental, creates the timbre of the sound you're listening to. Arun, that's pretty funny. One thing I didn't get tired of with Miss Saigon is the paycheck I got every week. Okay, and my pension that I'm collecting now from that show. Okay, so so this is a sine wave. It's a purest tone that you can get. It has pure sine wave is just fundamental with no overtones, and this is what the waveform looks like. And I'm going to show this in a Pro Tools session shortly. A triangle wave sounds higher, richer, and a bit louder because the fundamental frequencies is joined by the odd harmonics, right? 3, 5, and 7 times above the fundamental. So you get something that is represented by this kind of a shape. And from here to here is one cycle. And the cycles are important because the number of cycles in each second determines the actual pitch. So the more cycles in a second, the higher the pitch. So you can get 440 cycles per second, or hertz, they call that. That's A, above middle C, I believe. Square wave, still odd harmonics, but the odd harmonics are louder relative to the fundamental frequencies, so they have a greater impact on the timbre of the wave. And it ends up looking like this, right? So one cycle is from here to right here. And then sawtooth, which is called ramp because it looks like a ramp, right, is the most complex. Every harmonic is present at gradually decreasing levels. That means the higher you get, the softer the harmonic. And then one cycle would be, let's say, from here to here, or from here to here. All right, keep that in mind. All right. So these look like lines, correct? They're just like straight lines, all these audio clips. And the way that I've got this set up is that the first area here, these are all sine waves. These are all triangle waves. These are all square waves. And these are all sawtooth waves. And then I have them left and right. And so there's two of them. And they're in different pitches. Actually, this is not color coded correctly. Let me fix this. All right, so left and right. Give me a second here. For some reason, I have everything selected, which I don't want. Okay, great. So let's do this. Let me make these bigger, huge. And then I'm going to solo this one. Now, you guys are in mono, and I'm going to zoom in. And as I zoom in, you're going to see that the wave actually looks, right, like that sine wave looked in that opening picture. So let me play this. So that's 440, so that's an A, and that's a pretty obnoxious sound when it's just played like that. Now, that's also A, and that's coming out of my right speaker. And that sounds like a hearing test. Now, if we zoom in really close, right? Well, before we do that, let's listen to the next one higher, which is 660. This is a different pitch, 587. Oh, I see. So it probably plays a chord. Right. Okay. So let's take a look at this one and this one. So this is 660 and this is 440. Right? So you can see that from here to here is one cycle. Let's do it this way. I'm going to go from where it crosses the zero line, even though some people think say it's from the apex of the sound. So if I go from here to here, that's one cycle. And it takes up 1/100th of a second. I'm looking right here in Pro Tools. If I do the same with this, right, it takes up 2/100ths of a second. So this is twice as long as this to complete one waveform. Now, does everybody understand the difference? I know that the people that have taken Audio MIDI 1 and 2, 1 and Recording Studio Fundamentals know the answer to this. But the three of you that did not take that class, which would be Arun, Russell, or maybe Kevin and Roberto. Maybe Russell doesn't. I didn't do this last semester. Okay. The part above, this is the zero line right here. I forget what they call that exactly, but the part that goes up above it and below it, what does that refer to?
The amplitude, I think.
Correct. So that's the volume of the sound. So if this wave went up like this and down like this, it would be louder. All right. I mean, you can resize these, but you know, it would be louder. I've recorded all these at the same volume. From left to right determines what?
The pitch.
Correct. The frequency. Frequency. How frequently it does a complete cycle every second. Frequency, right? Now, I'm not sure this is going to work in mono, but let's just look at the purple one. And you see on my recording here with the purple one, these waves don't seem to be doing the same thing, right? In other words, they're crossing the zero line at different times, right? So this is here. And even though these are both 440, this one is here. So they're in different parts of the waves at the same time, which means that they are not in completely good phase. So let me just show you what phase is. So I'm going to separate this out at the zero line, and I'm going to use shuffle and delete that. And then I'm going to do the same thing right here and delete that. Oh, now I'm out of phase. Excuse me. Let's go right here. So I've done this incorrectly. So let me do this right here. Delete. And right here. And delete. And now these are in phase. So let me solo this. Now they're both playing at the same time, at the same volume. And because these waveforms are what's called in phase, meaning that they are doing the exact same thing. They're both the same amplitude, and they're both crossing the zero line at the same time, in the same direction. That's in phase. So I'm going to play the first one, and when I play the second one, what actually happens? There's the first one. I'm going to add the second one. One thing happened that you guys could tell. What?
It ends up adding volume.
Right. It doubles the volume. So it just gets louder. The other thing that happens that you can't tell, and if you probably will be able to tell if you listen with earbuds on the YouTube review video, is that it also, when I play the top one, I'm hearing it out of my left ear. And when I play the bottom one, I'm hearing it both out of the center. It's not like I'm hearing two waves, one out of the left and one out of the right. All right, so it collapses the stereo field down. Now, stereo miking, which we're not going to do, but I have to talk about it, and that's where phase is a big issue. You have two ears, one on each side of your head, right? They're at the same spot in your head, so that when you're facing a sound source, the sound source hits and it reaches both of your ears at the same time. So it's most likely in phase, right? So I have a sound source that's right here. I've got one microphone here and another microphone here. The sound source is hitting this microphone first and then hitting this microphone. And what will end up happening is what the original version of the wave looked like, with a little bit out of sync. And that causes problems with the stereo field when things are out of phase, and also with when things are collapsed down into mono, and it also reduces some of the low frequencies. So that's why it's very important when you're miking in stereo to always measure the distance from the source and make sure that's really, really close together to the same. But let's continue on with this little experiment. And what happens if I reverse the phase? So if I go right here, where it's crossing the zero line, and I delete this, you notice that now it's like the inverse, right? So I'm going to play just the top one, and I'm going to add the bottom one. Now, are you hearing anything right now? It's very, very, very soft, correct?
I'm hearing nothing.
Right, you're hearing nothing. If I unsolo the bottom one so that only the top one is playing, you're hearing something, correct?
Right.
And now you're hearing nothing when they're both playing at the same time.
Right.
I can hear a tiny, 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 tiny little bit because they're obviously not exactly out of phase, but it's practically nothing. And so what's happening is that as it's going through the amplitude cycle this way, it's canceling each other out. So when this one is at peak going up, this one's at peak going down. So they cancel each other out. So think of it like speakers vibrate like this. So if you put your finger on a speaker, you'll feel it vibrating. So just imagine if this one is vibrating out while the second speaker is vibrating in, and you're getting this kind of a thing, right? So this one is volume, and they're going so fast that they're canceling each other out, right? So that's sort of what's happening here with this. So that's a thing to be careful about with phase. That being said, you can use phasing to increase the stereo field, which you won't be able to tell. But if I just pull this over a little bit, right? So from my perspective, I'm now hearing two sounds, one in my left ear and one in my right ear, whereas before I was just hearing one aggregate sound because they're a little bit out of sync with each other, but they're not completely out of sync. So they're two distinct sounds instead of the same sound, just adding volume on top of each other. All right, let's move on to the next sound. And again, this is really difficult when we're in mono over Zoom. Okay, triangle waves. Let's zoom in on that. And you can see that there's a triangle wave, right? It looks like a triangle. A little buzzier, right? Let's get this in sync. Ah, come on. Jeez. All right, so that looks to be in phase now. And again, it's twice as loud. Now, also to invert the phase, what you can do is you can add in Pro Tools, they have the trim. And the trim plugin has this little guy here, which will flip the phase. And you see now it's no volume. So again, it's canceling out of phase. And let's listen to a square wave. All right, so that's even buzzier, right? And you can see that it looks like it's a square. This little portion here and this little portion here. Those because those harmonics are a little bit louder than they are with the triangle wave. So sine, triangle, square. Now, another thing here to realize is that you could see that these are all at about the same volume, right? So in other words, they're very close. So if I bring the gain up on this, you could see that waveform gets much bigger. But if I pop this down, they're all at the same volume. And you can hear how when you add more overtones, the sound gets louder. It's perceived to be louder by you. That's a sine wave. A little louder, even louder. So these have the same amplitude, but they each have more pitches in them. They've got more overtones. So there's more information coming to you, which makes it seem like it's louder. Okay? All right, some of this other stuff I have here, it's kind of useless in mono, so I'm not going to go over this. Oh, it's one of the failings of Zoom among many. Any questions on this, right? So they're basically the 4 waveforms. They each sound different because they've got different amounts and volumes of overtones present that are sounding at the same time as the fundamental of each pitch. You've got amplitude, which is the height of the wave, and you've got frequency, which is how many times it does a cycle in 1 second. When 2 identical waveforms are in phase, the waveform is parallel on each, right? On each track. When they're out of phase, they're the inverse. They look, and so instead of going like this, they go like this. So when things are in phase, you add the 2 tracks together and it's like you're just doubling the volume. When things are out of phase, because things are going on the opposite sides of the 0 line at the same time, they cancel each other out and you get no volume. That's just something you need to know. And if we were doing class in the studio, we'd be doing stereo miking techniques and experimenting around with that. But sorry, can't be done at this stage. But some of you, most of you who took Recording Studio Fundamentals, at least you had a little taste of that. So